The simple principle of generating electric current. All we need is to move a conductor, a wire, across a magnetic field. It can go back and forth, or it can go round and round. Here is an ultra-simple design of a generator based on this principle. We have a coil of wire that can swing backwards and forwards, cutting through the lines of magnetic force between the north and south poles of the magnet. Watch the animation that follows and note the movement of the meter's needle as the coil of wire swings backwards and forwards. The animation showed that as the coil of wire moved to and fro across the magnetic field, an alternating current, that is AC, was generated. Instead of an animation, here is real video of a very simple alternating current generator. Watch the galvanometer needle as it reacts to the changing current. Here the energy source is chemical energy in human muscles. My chemical energy is converted to movement energy, and the movement energy is converted to electric energy as the wire cuts across the lines of magnetic force between the north and south poles of the magnet. All that Eskom needs to do is to find effective methods of moving coils of wire so that they cut through magnetic fields. The energy to do this can come from various sources. In principle, it does not matter whether a conductor is moved in a magnetic field or whether a magnet is moved past a stationary coil of conducting wire. It is simpler to design a generator that moves a magnet past stationary coils of wire. Watch this animation of a flashlight that does not use a battery. Shaking the flashlight to and fro causes the magnet to slide back and forth through the coil, generating current and charging a capacitor. The white light-emitting diode can shine for up to 20 minutes before the device is recharged. The national energy provider, Eskom, has to apply these simple principles, but on a very large scale. However, energy cannot be created, nor can it be destroyed. Energy can only be transformed from one form to another. So, if we want a specific kind of energy, we have to convert energy from some other form. For example, electrical energy can be transformed into light. Chemical energy can be transformed into light and heat. Chemical energy can be stored in cells to be transformed into electrical energy later. Solar energy can be used to heat water. Energy from the sun can be used to generate electricity for a small motor. Mechanical energy can be transformed into electrical energy and then into light energy. Here's the flashlight that I drew in the animation. And instead of pictures, let's look at the real thing. In order to get this to shine, I have to move this magnet forward and back through the coil of wire. And if I do this vigorously, like that, I'm using my chemical energy from my muscles to change the energy from my muscles into electrical energy, which is stored in a capacitor at this end of the torch. And there you can see there's electric energy, and there you can see the electric energy has been converted into light energy. Let's do that again. Chemical energy in my muscles converted to mechanical energy That is being converted into electric energy, and the electric energy is giving us light, not a battery in sight. This means that to generate electric energy, Eskom has to convert energy from some other form. In thermal power stations, Eskom uses heat energy to make high-pressure steam. The steam has kinetic energy, which is transferred to turbines coupled to electric generators, which convert the movement energy into electric energy. So, heat, for example from coal, boils water. This makes high-pressure steam. The steam moves along pipes leading to turbines. These spin, that is kinetic energy, making the attached generators spin too. The spinning generators move magnets past coils of wire, producing electric energy. Let's look at a systems diagram for a thermal power station. The input for all types of thermal power station is the same. Perhaps coal dust is burnt, heating water to make steam, or gas is burnt and the heat boils water, or a nuclear reaction gives off heat and the heat boils water, or we can even use the sun rays and focus them onto a water container and the heat will boil that water. In all thermal power stations, steam spins a turbine and the turbine spins a generator. The output from the thermal power station system is electric energy, and the electric energy comes from the generator via step-up transformers and is fed into the national grid to be passed around the country for consumers.